Nearly all of us have used aspirin at some time in our lives, but not many people know that for hundreds of years a related compound from willow bark was used to relieve pain and treat fever. In 1899, a German chemist named Felix Hoffmann worked for a German company called Bayer, experimented with aspirin and gave it to his father, who was suffering from the pain of arthritis. With good results, he then convinced Bayer to market the new wonder drug. Aspirin was patented on Feb 1900s. Approximately 35,000 metric tons are now produced and consumed annually, 100 million tablets every year. They are used not only as painkiller, but also to treat fever, inflammation, heart disease. In manufacturing plant, the key test is determining the exact amount of aspirin, the active pharmaceutical ingredients in each tablet. The chemical name of aspirin is true-ethanoyl-oxybenzene carboxylic acid. Aspirin contains carboxylic acid group, ester group, and phenol group. Aspirin is a weak acid, so only partially dissociates in water to form an equilibrium mixture with its carboxylate and hydronium ion. When a weak acid such as aspirin reacts with a strong base, the carboxylic acid group is fully deprotonated to form a carboxylate ion and water. A titration experiment with aspirin and sodium hydroxide. This is an example of weak acid and strong base titration. We represent the titration data using a graph of the volume of sodium hydroxide solution plotted against pH. It gives a characteristic titration curve. As you add an AOH solution, the pH increases. Eventually, all of the aspirin molecules have dissociated, and all of hydronium ions produced are neutralized by hydroxide ion. This sharp increase in pH indicates the end point of the titration, which we can visualize using a suitable indicator compound that changes color within the required pH range. Now I invite you into the quality control laboratory. These are first-year students of Bukovinian State Medical University. They have medicinal chemistry practical class and they are investigating quality of aspirin tablet. Now I suggest you to perform a titration experiment and determine the exact amount of aspirin in a tablet remotely. You can do it by yourself. Why not? Scan this QR code and let's investigate together. Welcome to Titration Screen Experiment. Click Quick Start and choose Level 2. I suggest you a short review of this online activity. To begin with aspirin preparation, you need to dissolve some aspirin tablets. First of all, add 10 tablets on the mortar and grind them to a fine powder. Then dissolve the aspirin and transfer it to the volumetric flask. Make up the solution to 250 milliliter by adding water drop by drop. Next is preparing for titration. You need to set up the beaker for the titration. The pipette has already been rinsed with water. Now it needs to be rinsed with solution. You should perform it as shown on a video. Next, you should measure exactly 25 ml of aspirin solution and transfer it into the beaker. Next is Burette Setup. Start by rinsing the burette with distilled water. As a safety, always make sure that the top of the burette is below eye level when you fill it. Rinse the burette with some of sodium hydroxide solution and fill it by it. Remember to close the tap when filling the burette. Next, you'll run the titration and monitor the change in pH using pH meter. You will use the data to select an appropriate indicator. We can use an indicator compound to visualize the endpoint of the titration. Match the different indicators with the pH range at which they change color. So we can make a conclusion that two different indicators can be used. It is bromoethanol blue and phenolphthalein. Next, you need to perform titration of aspirin solution. You will be using phenolphthalein indicator, which is pink under alkaline condition and colorless under acidic. Start by reading the initial volume in the burette. Click Start to begin running the solution into the flask. Continue adding the sodium hydroxide until the point at which the solution in the flask becomes pale pink. Now read the final volume in the burette and record your answer in the table. You need to calculate the volume added by subtracting the initial volume from the final volume. You should perform first and second accurate titration. After that, calculate the volume added. Decide if you need to run another titration. If the volume added in the first and second accurate titration are not within plus minus 0.05 ml, you will need to perform further titration. First and second titration are not accurate, that's why you need to perform the third one. Result of second and third titration are accurate, that's why average volume added is 18.55 in our case. Last part is titration analysis. First of all, calculate the amount of mole of NaOH by using of initial concentration of NaOH solution and volume added. Next, let's identify molar ratio from equation 9 to 1. That's why actual amount of substance of aspirin is equal to NaOH. As amount of aspirin is given, you can calculate the mass of aspirin by multiplying by molar mass. So, next number of tablets in your sample under investigation is 1. Next, you should compare result of titration with quality standard and based on your mean concentration, the amount of aspirin in one tablet is not within the acceptable range as specified by the quality standards. So, well done, you finished this investigation. Goodbye.